scheduled for right now, but we're going to go ahead with at least the second and probably the third section of this discussion, and then after that there will be another presentation and the business meeting, which we'll get to afterwards. So what we're doing, we started off with 101, giving the very basic information. Now we're going to start to get into the details of people that have joined the project, what should they be doing within the project to get the best results. And later we're going to talk about the most exciting part, strategies that you can use this information to advance your own research. Okay, so here's just a list of suggestions, things you can do. Once you're in the project, you've done a test, you're a member, you have a profile. These are things you can do within your profile to make sure you get the most out of it. Make sure you include a name for your most distant known ancestor. This would be a Reynolds connected to your Y line, or the Y line of the person that took the test. Make sure you identify whoever your oldest person is, whether it's a Reynolds progenitor or if your great-grandfather is the oldest known Reynolds you have, with good confidence, then you should use their name in your profile. You should join the Reynolds project, you should join Surname projects of your other matches. You should also join haplogroups that are relevant for your lineage. We won't get into that right now, but it is important, and if you have questions about that, feel free to talk to any of your administrators who will point you in the right direction. You should be sure to invite Reynolds named matches that you have. There are Reynoldses who've tested with family tree DNA, they're in the database, they show up as matches to us in the project, but they haven't joined the project. It could be they don't know that there's a special project that could help them out. It could be that they tested a long time ago and have passed away, and their results are still in the database, but please reach out to people that aren't in the project and invite them to join. Having their information in the project will also help the others in the project. There's an activity feed, like a discussion board within the project where people in the Reynolds project ask questions, get answers from administrators and other users. It's a good thing that we'll be focusing on even more. Contact your administrators with any questions about your results, about how you might relate to Jim or Fred or whoever. And there's also space in your profile where you can add a picture of yourself and other things about what you're researching that people can see, and it may encourage them to reach out to you. Okay, so something we need to say that's really important. When you join a project, whether it's a Reynolds project or a haplogroup project or anything, the administrators will get your kit. Each of these lines is a different man that has swabbed and joined the Reynolds project. So right now this is anonymized. All you see is last names here. And the self-reported most distant known ancestor. So these are people in the 18th century, etc., that they have chosen to put here for other people to view. Your administrator, when they get your results, they will look in the database and see who are your closest matches. And then the administrator, almost always Nancy, will place your kit into one of the approximately 40 different distinct groups in the Reynolds project. So you might take a test, and when you log in, you land, and you see that this is your kit number, and here you are. You're placed with these other people. This is called, we refer to this as a group of men in the project. And how you are grouped is really important. What we're looking at now is two groups. One up here. This is an I1 group. This is one group, and a second group down here. And it's important because this group is genetically separated on the Y chromosome from this group by 27,000 years. The Reynoldses here are not. related to the Reynoldses here on their Y chromosome line. This is very helpful for genetic research. Because it's easy to see who you are not related to. So this can lead to the question, okay, we're all Reynoldses, but why are there so many distinct groups within this project? Wouldn't one think that we're all at least kind of closely related? Well, there's the backstory. So surnames started to become fixed and inherited from father to son to father to son sometime in the Middle Ages. In different parts of the world, this was at different times. In Scandinavia and Wales, for example, it was in the 17 and 1800s. But in most of England, surnames became fixed between, something like 1200 to 1500 AD. Before that, people were just known as by names, like John the Carpenter, or something like this. And that was not inherited. His sons were not Tim the Carpenter. They might have been Tim John's son, or Tim that lives by the well, etc. Okay, so the genetic diversity in the project represents the genetic diversity among the men that adopted the Reynolds surname during the Middle Ages. And during the Middle Ages, there were men of tremendous genetic diversity, including in England, including where people started to take up the Reynolds name. So, what we have within the project are some basic groups. These are called haplogroups, but they guide how the men are clustered in the project. For example, the folks in the top cluster that you saw on the previous screen, that batch of 12 or so Reynoldses, they belong to haplogroup I2. Elsewhere in the project, there are, okay, so as for the history, the I2s are very distinct from these other groups because the latest thinking from population geneticists are that the I2 folks were some of the original human inhabitants of Europe. These people, they were hunter-gatherers. We're talking 10,000+ years ago. They were almost totally replaced by folks in groups, for example, G2A. They were part of the early agricultural expansion out of the Middle East that brought agriculture across Europe and mostly replaced the hunter-gatherers that were there. But they were very genetically distinct from the original people. Then, all across Western Europe, we have the hugely common and the very prevalent groups of I1, R1b, R1a. These people are associated, according to population geneticists, with the Proto and the Indo-European folks that spread from Central Eurasia and brought all of Europe Indo-European languages, all Germanic languages, including English, all Romance languages, Gaelic languages. All of these languages stem from folks that populated Europe from Central Eurasia during the Bronze Age, something like 4,500 years ago. These folks, they had bronze, they had horses, they had chariots, they were lactose tolerant, and they wiped out the people that were there before them, including most of the early agriculturalists, most of the folks that already were hit by the previous wave. So these are the most common major haplogroups, but then under this there are lots and lots and lots and hundreds and thousands of different branches and lineages under these, but this explains why there are huge distinctions between some of these genetic clusters in the group, including Reynoldses. Because we have Reynoldses from this group, we have at least one, if I remember, we have at least one Reynolds from this group. We have lots of Reynoldses from these groups. We have Reynoldses from Group E and other groups that aren't even covered here. But that can help understand the huge variation. So there's a lot of variation in the surname Reynolds. That relates to how the name was taken up. So as for typology of surnames, there are some single origin surnames, and these are very rare. There's a fellow named Jim Houston that has done extensive research on his line, and he has traced every living Houston that was willing to test. He has covered their lineage, and they all connect to one person that lived in a particular place in the 1300s in England. And so they know all of those people descend from one patriarch. On the other end of the spectrum, there are surnames that are extremely common. These are occupational names, description names, things like that. There would be huge genetic diversity in people with these names because they're taken up based on their occupation, and every town and village had its own carpenters and tailors, etc. And then there are intermediate surnames that fall somewhere in the middle. They're not rare, they're not common, but they were taken up at more than one place by more than one genetic group of people. These include names like Reynolds, Graham, Thurmans. I mean, these lists would go on. There are lots of ways to typologize surnames, but this is one, and it helps us understand the group, why there are genetically distinct groups in the Reynolds project. Any questions about this before we move on? Okay, here's just a quick snapshot of the project page. When you join the project, here's some basic information. You see each row is one project member and their kit. Their results are over here, a string of numbers. We won't get into the details of those, but these are just things that will help you understand what the information about your kit means. Country is self-reported by the kit numbers, so that wouldn't be a surprise to anybody. At the top of each group, we have given our best guess as to what the haplogroup of each group is, as in what is their address on the tree of humankind. Sometimes this is best based on high-resolution tests where we actually know the answer here, but if people haven't done high-resolution tests, then this could be just an estimate based on their proximity to people who have done high-resolution tests. Earlier when we were talking about the genetic signatures, for example, of the Reynolds progenitors, and we have this alphabet soup of with the name of the SNP, that will show up in your test results over here. For example, the people with the green SNP labels, they have actually taken a test that confirmed that they are at this address on the haplotree. The ones that are red, they haven't taken an actual test to verify this, but Family Tree DNA has provided this as an estimate. So based on the results that they did test, they're able to estimate with high confidence the haplogroup, and the estimates are indicated in red. One more thing that can help you understand your results is the columns either have red headers or they have blue headers. The blue headers are the more stable markers that are less likely to mutate. The blue ones are less likely to mutate. The red markers mutate more frequently. So when you get your results and you're a genetic distance of 4 from somebody, that's not the only important information. It matters which markers are different than you. Because if you have 4 in highly mutating areas, that's probably a closer match than if you have a difference of 4 in slowly mutating areas. Okay. So we had some suggestions that of things that we would want to walk through with everybody. Why don't we save this as a separate exercise that, if time allows, we could walk through and do some of these demos. We could also do it on a sort of one-on-one basis, or do this with people over the phone. I think it's useful to understand, but we'll save it, and we could do it at the end if there's interest and if there's time a little bit later on. So when you're a group member, something you should do is look in your group and see who is genetically closest to you according to the mutations that you have. Well, we can't get this from the family tree DNA site itself, but you can take all of these values and you can put them into a utility that that estimates how close you are to each of these other people. So, here for privacy we call them A, B, C, D, E, F, G, but you could have kit numbers or something like that from your cluster in the project, and you could load the people in. So what we see here, this tool does something very useful for us. It estimates in years how closely related the different kits are to each other. And so, the green are more closely related, the yellow, intermediate, the red is sort of barely related. And then we have some that aren't even colored because they are very, very distantly related. We have kept these people, M, N, and O, in this group within the project because they do match these other people. They just match them very far back in time. And these are the people they match closer than anyone else, anywhere else in the project. So it's where they belong. They're just not closely related. And there aren't really census records and probate records from 2,490 years ago, so it might be tough to find their common ancestor, but they are relatives, just deeper back in time. And this tool actually takes into consideration the mutation rates of different markers. And it makes assumptions that generation is every 30 years. When you're inputting the data into the tool, you can change those parameters if you want. If you say, no, well, my line, reproduce every, something else, you can tweak it and get estimates for your group.
Can you tell me now, where do you get this tool?
It's online, and when folks get, I'm going to distribute a copy of this presentation, and this is a hyperlink. It's called the McGee Surname utility. It was created by a Surname project administrator that was technologically savvy and saw that there was a need for a tool that would process this for everyone. So it's available online. Okay, so I'm going to ask for questions. We have a we got some questions in advance. I want to try to answer these. So a question that came in advance from Darla, actually. She asked, how can I prove that I'm not a descendant of a certain RFA lineage? So as of now, we don't have the lineages, we don't have the signatures of all of the groups identified yet, but we have some of them so far. And for example, if someone is in one of the groups that's R1b, then we can say they are almost certainly not a descendant of James, because as we're working on the James profile and what his genetic signature is, it's looking very certain that he is type I1. And so if someone like me, I'm R1b, if you're in one of the R1b clusters, then no need to spend time researching James and your lineage. Another question that came up before we prepared for this says, my family appears to descend from James, or this could be any of our progenitors. My family appears to descend from James, so what can we do to get beyond James? This is probably a question that folks in RFA have asked again and again for decades about James or one of the other key progenitors. And the best I can do to answer this is to suggest that folks in James's line, or whoever else's line, work with their deeper matches. So they will have close matches that connect to them within the last couple of 100 years. But if you look at your more distant matches, the people that match you at 9 or 10 markers out of 111, they may be Reynoldses, they may not. But it would be good to get in touch with those people. In my case, for my exact test, I don't have any close, immediate close relatives, except for the fourth cousin that I actually recruited to do this. But I match a couple other people's Reynoldses from in this room, and we connect something like 400 years ago. We don't know the names of the ancestors yet, but they match me at something like 9 or 10 out of 111. And so in that case, we have used the data to identify Reynolds named relatives beyond our brick walls. And so it would be the same case with these folks that were, even the folks that lived in the 1600s. Another thing that people can do and is identify places where we think these progenitors came from in England or Ireland or wherever we think they came from, and try to recruit Reynoldses to join the Reynolds Family Association to do this type of testing. And by expanding testing in the motherland, I think these are the best approaches we could have for getting beyond our progenitors. Do we have other questions for this session? If everybody's okay,
it's probably the case that getting beyond James with DNA is better than getting, it's easier, more accurate than getting beyond with trees, right?
Yeah,
because it's more scientific, right?
Yes. Also, there's the tree lineages. Maybe those may be exhausted. It may be that researchers have been looking at the problem from the perspective of paper genealogy for decades or centuries, whereas now there's this new tool. Okay, that's exhausted. Maybe something will turn up in the coming decades. While we wait for that, we can use
the thing that's exhausted is the paper records, or the real hard evidence records.
Yes, that's right. The traditional approaches may have exhausted everything that's available. Maybe, but we have these new tools. Is everybody okay if we just go into the third section and keep on going, or do people want to break? All right, good. Then we will just go straight on the next one. Good. So, this is going to be the most practical of our session. And in this section, we really want to talk about strategies that people can use to advance their research. So, at the project level, administrators are using these tools to pilot approaches that can be used by groups across the project, and to apply these things more generally. All members should use things like this and other strategies within their own cluster to try to solve their problems. So we're going to introduce two strategies. The first is targeted testing, and the second is going to be finding your most distant known ancestors' DNA signature. We've hinted at these kind of several times through the earlier sessions. We're going to talk about practical examples about how we're doing these. So, in a general sense, the process for targeted testing goes something like this. You test your own line. So you have full confidence in your own, in your baseline. Okay? Then you develop a hypothesis. It could be something like, Isaac is the father of my most distant known ancestor, Joseph. Then you trace that candidate's line down, following their male lines, who had sons, until you get to the contemporary era, and you reach out to Reynolds men and recruit somebody to do one of these tests. I'd say my success rate is fairly high. Probably half of the people that I've reached out to do something like this have agreed to do it, so it can certainly be done. And then you compare your results, and you analyze the information, reach out to your admins if you need to, and then you develop you make a conclusion, develop a new hypothesis, and proceed from there. And I'll give you a specific example of how I did this to validate a hypothesis that had been hanging over my most distant ancestor for as long as I've been doing genealogy. So this is my tree. It goes back to a fellow named Joseph. And every single online tree says Joseph's father was this person named Isaac, here's his mother, these are all his siblings, every single tree. This is going back before Ancestry was even really a thing. Ancestry.com. And everybody I'm in touch with, says, here's the answer, but there is absolutely no paper evidence connecting the two. They are not listed on a census record, he's not in Isaac's will, they are not connected at all in any traditional evidence form. And so we want to validate. So Isaac is a rich, connected guy. When he died, he gave out lots of land, lots of cattle to many children. My Joseph is first found as a pretty poor guy. He doesn't own any land. He owns, I think, a horse and maybe a cart or something like that. Isaac lived in northern Kentucky. Joseph lived in southern Kentucky. All of this suggests, why on earth do we think that Isaac is Joseph's son? So, the hypothesis that I'm going to want to test here, genealogy or family history, and that's it. Well, I think he tested to learn about his connection to his surname group. Maybe he belongs to a club like ours and goes and meets them every year, and they've been comparing paper research for years or decades, and now he gets these results, and he finds out he is not of that line anymore. People could take this across the spectrum. We said, look, it's not necessarily a bad thing. Somebody could have been adopted. There are lots of legit reasons for this. But he made it clear that he isn't interested in discussing this further. So, okay, that's part of how this works. Some people get surprises. But the fact that he has tested was helpful for us because it helps us understand which markers are unique to our group and distinct from his group. So the next thing I want to discuss is these blocks. So these are blocks of mutations or SNP markers that were unique to this tester. This Reynolds tester was positive for these mutations that this tester was negative for. So these mutations happened somewhere down this line. We don't know if they were right here or they belong down here further, but they're distinct for Joseph Sr., son of James. They're somewhere down his line. These three markers are distinct for James's son, Francis. Somewhere between James and down to this living Reynolds tester, these mutations occur. We don't know if they were right here, probably not. Probably they're spread down here. Something, one maybe here, one maybe here, one maybe here. We don't know. But what we're doing now to try to identify where these markers belong is we have Randy. Randy said we can use his name in this. Randy belongs in this picture. Is it fine if we point you out, Randy? Randy, is it right? This is Randy, right down here. And Randy is doing a he's testing only for these markers. He's done a STR test. He's now testing for these specific markers to see if any of them happened right here. I guess the best case results would be is if Randy is positive for at least one of these, then that would mean that it occurred between James and his son, and that would mean the one marker Randy is positive for is shared by Randy and this tester over here, which means that this happened between James and Francis. The other ones probably occurred down this line somewhere. The value of having one identified as happening just above Francis is then that's Francis's terminal SNP. And anybody that descends from Francis, either in the project or in the RFA or anywhere, could test for that single marker and know that they descend from Francis Reynolds, who was born in 1662. Because that marker would pass on indefinitely. So what we want to do is we want to get these blocks and we want to move them as far down as we can, because we have some men in this group that we don't understand how they connect. They can get back to certain ancestors, but we don't know how those ancestors connect to this group at all. I should explain the red lines that are in here are estimated connections or educated estimated connections. The red blocks in here are folks that they're estimated ancestors, as in they think that these are their ancestors, but they aren't fully certain. Do we have questions about this or how it's used or what it can do? David?
In the blue box,
yes.
I can't read that from back here, but
yes.
It looked like there were some years back that you were talking about.
So
these, some of those,
good question.
27,000, and that says 492.
Yeah.
The concept of surnames, is what you're saying is they're from the same DNA, but
Yes.
they're not from the surnames didn't start, 27,000 years ago.
No.
Right.
To the best of our
years ago.
knowledge, let's put it that way.
So, good question. So, the age of this block of markers is estimated by one group of analysts. It's estimated that this block is 2,700 years old. YPP is years before present. So, people that match people in this project that share these SNPs with our people, but do not share these SNPs, then the people that are positive for these and negative for these, they split off of our line before surnames were used, about 2,700 years ago. Before surnames were used, I don't know, what is this?
Surnames weren't used before like 1,200, something like that.
1200s onwards.
For the common people, even
Yeah, that's right. So these are estimates, meaning that anybody who's positive for these and negative for those below it are on a branch that split from ours 2,700 years ago. Or we can look at this one, and so this was determined by by analysts that run a company that does this sort of analysis. This estimate was done by me based on kind of similar results to process to what they use. And this, we can estimate this number by counting the number of SNPs that occurred below this block. For example, this one, these three, this one, the one that's over here, and so when we did this at first, we took the average of 4 and 2, because they're 1, 2, 3, 4, and 1, 2. This was before these results were part of the picture. So we have an average of 3 SNPs for each lineage, and you multiply that by 144. That's the average time that Mutations occur in those, remember the light blue portions of the Y chromosome? On average, mutations occur in that region every 144 years, and you assume the average man that tested is 60 years old, and you come up with an estimate of the branches underneath this block is about 500 years.
When I said 1200 too, I wasn't talking about 1200 years ago, I was talking about the year 1200.
That would be the year 1526.
1526.
It's more, it is more like 14 or 1500 instead of 1200.
Yeah.
So it's not, it's
Different
500
areas adopted at different times. They're probably different classes.
500,
started
600
adopting.
years ago. We're talking about 500, 600 years ago, not.
Yeah.
Yeah,
So,
so
and this would match our hypothesis that these two men, the green blocks down here, our hypothesis is that they connect at James, and this is telling us that the blocks just above James are something like 500 years old. It doesn't give us an example. This is I shouldn't leave it as 492. That makes you think it's really precise. It's not. It's something like 500 years. And I can't.
Which
give
is
confidence interval
about when
because-
Surname started to be used.
Yeah.
I see.
Okay.
Yes.
1500, you know, 1500. I've seen a few.
Did you have any years for the lower blue blocks? I don't see any.
No, because
Doesn't
what
have
comes
those
into play is the statistics, which are based on huge data sets. Once you start applying it to n equals 1 and 2, it breaks down. It can make you think that, can give you high confidence when you shouldn't have high confidence. So that's what we're doing. That's what we're doing with the James project, or this pilot project to demonstrate how this can work. But really, any of the other RFA lineages could do something similar to get these signature SNPs. And any of even the smaller, more recent groups, even if they're not part of the RFA lineage chart, anybody could do this within their group to get sort of high confidence relationships between their ancestors.
What are the little gold boxes there?
Yeah, good question. So the little gold boxes are the STR mutations. So remember, there are two types of marker mutations we look at. All of these gold box people down here have had only STR tests. And so building this tree, a genetic tree, is a two-step process. First, you build the backbone using the known genealogy and the SNPs. You make the backbone. And then, based on that, you can use the STR results. Because if you remember, the STR results are lower confidence. They could mutate one way, then mutate back a few generations later. So those should not define the backbone of the group, but they can help define structure in places where you don't know the ancestry. It can help you understand where branches are likely to have split off.
Are you still, when you talk about the purpose though, are you, your purpose from a genealogical standpoint is to be able to say that these two groups could be merged or something like that, right? Or these are related people? In other words, reducing the number of Reynolds lines that there maybe are. Or something
Yes,
like that.
I think that is probably what will happen, is that the number of however many, 46
Well,
lines
the idea
may converge down to
well,
something less.
most people with the surname are interested in, you know, what is the origin of the surname? You know, like there may be
40
15
answers.
origins of the Reynolds surname, 15 different places where that originated. You know,
Yes.
15 different people, if you will.
Yes, great, excellent.
Where
Each of these groups would have a
surname Reynolds
distinct
was
origin.
associated with that group. Yeah. Right. Sorry.
And that's all I had. Oh, I just have one more slide for the presentation to talk about some exciting things that are coming up in the future for the project. So, one thing we've been talking about, we don't have a process or criteria yet, but what we want to do is we want to open up the project so that people that have, not only have YDNA results, but people that have autosomal results can also join the project and be part of the discussion and the activity feed. We will have to come up with what the criteria are. We'll have to validate that they do actually connect to Reynolds, but it won't necessarily have to be on the males line. There's some advantages and disadvantages to this. One, autosomal DNA is a whole other, it's a totally different type of test that gives totally different types of results. In some cases, they can be very hard to understand, sometimes very easy to misinterpret. So we're going to have to figure out the best way to handle that, but we think it will open up the membership to bring in a lot more folks that are connected to the Reynoldses. And they will be able to contribute to the project also. We may have mentioned before that there is a separate Reynolds project, Family Tree DNA, with 22 tested men. But the project had no administrators. Nobody had volunteered. Perhaps the last one passed away or just wasn't interested in still doing it. But it was an orphaned project, and we decided that this is something that we could wrap in. We won't manage it as a separate project. We will wrap it into the Reynolds project, so it will also include additional McReynoldses. There are already some McReynoldses, but we're going to include these other men. And we will place them in the appropriate group, whether they are grouped together or whether they are grouped across different Reynolds buckets, we will see. Even within their own group, they also have very distinct groups.
Do you remember like we were talking about the Reynolds book, the original Reynolds genealogy book that was published, the first one? And it has lots of different spellings and stuff like that. That's whether it was
1973, we're looking at that. That's the one we were looking at?
Yeah. No, not the one we were looking at. I'm saying the one that somebody spoke about it. I have a copy of it, but it's on the website. But
Yes.
it has not, it's not just like McReynolds is in it too, I think, and the Reynolds and that type of thing. Because the guy was trying to do it from a traditional genealogical standpoint, trying to do what you're doing with DNA, which is putting these all together, in one context, which is.
So they will be joining our group. We're going to continue as we discussed, looking to specify and make more precise the SNP signatures of the RFA line ancestors. We're well along the way with the James and Deborah line. There are also participants in one of the other clusters that have been working together. One of them already has a big Y, another just ordered a big Y test. So they are already working on this for their line. We'll be providing consulting on the technical aspects with it. We'll be looking for innovative financing solutions. I don't know, can we do something to have a mechanism that people can, as they pay their dues, they could say, oh, I want to donate a little bit of extra money to go to the DNA project? I don't know. It'd be good to know if we could do something like that. And we're going to be looking for ways for seed money to look at other critical RFA lines. We're also going to add something to where people can choose to self-report their lineage on an activity page within the project that would be visible to the other members. Especially as we bring in autosomal tested folks, the lineage won't be father, son, father, son, father, son, so it'll help if they can spell out their exact connection in a simple way. But these are things we're looking forward to in the next year, and I think there'll be a lot of interesting things to do. If folks have questions for discussion now, fire away. If you have one-on-one sort of things, we should cover them in detail separately. Yes.
So my male line is with my great-grandfather. So does my YDNA test count?
I don't know if I understand your question. You're saying, so you don't know the father of your, did you say your grandfather?
Well, my great-grandfather was a Reynolds.
Yes.
But I come from
Ah.
his daughter, who was a
Ah.
Reynolds.
Yes, so your Y chromosome should be connected to the Harrises
Right.
and would do well in the Harris project, for example. If you wanted to get a sample that would be relevant for the Reynolds project, you would need to find a brother of your great grandmother that has some living descendant. And if you want, we can talk about specific strategies for doing that.
A descendant of a brother of his great grandmother. Right?
Sorry?
A descendant of a male descendant of his
descendant of your
brother.
great grandmother. Who's a great yes. You'd have to find a male Reynolds name.
Have been.
Sorry, the details are not stated. Okay. Thank you all very much. Feel free to fire away questions by email anytime.
Before we go on a break, I just want to clarify, we have 3 more presentations today. The business meeting we're going to do last.
Right.
And then Regina, you have a presentation?
Yes.
And I wanted to take you live onto Family Tree and make sure you know everything in there that you can use, and make sure you've given Tommy and I everything that we need, so we don't have to seek you out. And, I'm happy to do it over the phone, but I can at least show you what we would like to have in there. So I just know the business meetings last. Regina,
Right.
It's up to you.
As far as